Hi, my name is Everett McFarland, and this is my roto molding presentation for ETM 2080. Alright, first so we had the yellow duck was our product. We used 2 ounces of low density polyethylene powder. The mold itself had a bit of grime on the contact edges. It had some pit marks in the body, so that definitely would end up kind of messing up our product a little bit. There's also some burnt residue on the bottom of the body of the mold. The mold material was made out of aluminum, as are the rest of the molds. The the equipment that we used for this was the mold. We had the powder, resin, the dye, the rotational machine, the securing plates. You need an Allen wrench. You needed separating tools, possibly. You need your sink to cool them down, and some heat-resistant gloves. The processing time per machine was 20 minutes in the heat for this, since it was low-density polyethylene, and 2 minutes to cool in the water, roughly. We measured the resin in a cup and the heat with the temperature scale on the measurement, or on the machine, and a timer to time it. The defects of the product were the fact that the dye was dripping out, had a porous surface due to the pit marks in the body, and the nose wasn't quite formed. For our orange pumpkin product, we used 108 grams of high-density polyethylene powder. The mold's condition had a little bit of grime on the contact edges and some small holes in the body. Once again, it was made of aluminum. We used a mold, resin, dye, rotational machine, securing plates, Allen wrenches, separating tool, sink, and heat-resistant gloves, the same as before. We also put this in for 20 minutes into the heating machine and used about 2 minutes to cool it down. We measured the resin in a cup, and we measured the heat on the scale on the machine and used a timer to time how long it was in the machine. This did not come out as a complete product. It kind of split in half, mainly because of it being high density polyethylene. It needed to be in for longer, and it needed to be a little bit hotter as well, because it was just starting to form. So if it was given another 10 minutes and maybe it was a little bit hotter, we would have had a pretty decent product there. Alright, the green Christmas tree, we didn't quite measure it exactly. We just kind of poured in half a mold of high density polyethylene. The mold's condition was not too bad. There's a little bit of pigment in the mold, and then just a little bit of material on the parting line face. Alright, the mold was aluminum, and of course we still used our mold, resin, dye, rotational machine, securing plates, Allen wrench, separating tool, sink, and heat-resistant gloves were the materials that we used. The processing time for this one was 30 minutes in the heating machine, and once again, to cool it, seemed to be good enough time to cool it. The methods that we used to measure it, we used a cup, but we didn't really measure it fully. We just kind of used that to pour, and then we measured the heat with the scale on the machine and a timer to time it. The defects in this one were less than, say, the pumpkin. The holes were where the product had too thin of a wall, but it also was leaking dye, so a little less defects, but they're still noticeable. The green clover, did about a half mold again of low density polyethylene. Some grime was on the parting surface, the parting line face. Once again, it's made of aluminum. Used the same equipment, and it was in for 30 minutes and cooled for 2. Once again, we didn't quite measure it, but we did use a cup to pour it in, and we measured the heat on the scale. And this one was leaking dye. There were some holes where it was thicker for some reason. The color wasn't mixed all the way through, and it obviously wasn't a uniform thickness. Some things that ensured a good part were, I think, a consistent measurement of our material. It looked like we didn't have enough on that Christmas tree to make it uniform all the way through. And if we would have used a proper heat, I think that would also ensure a good part. Our main example there being the pumpkin. I don't think it got hot enough to truly get that to be a good part. The mixing seemed to be a bit of a problem. This kind of ties in with our second bit here. Proper measurements of dyes, of the dye itself. It really should be measured and mixed better, referring to the dye, because that measurement needs to be a bit better so we won't have leaking when we pull the part out of the mold of all that dye. And then finally, I think we should use similar materials for the 2 molds when heating, instead of mixing like a low density polyethylene and a high density polyethylene when we put it into the heating machine. All right, some tests that we could do to test maybe what would help the best or make the best parts. Our first test, I think the dye ratios would probably be the best test, because it seemed to be a common trend where all the products had leaking dye coming out of them once we pulled them out of the mold. To do so, we would keep everything the same, except we would measure different amounts of dye and record if they were leaking at the end with the amount of powder resin that we used. So we would obviously keep that powder, or the amount of powder resin that we use, the same as well, but we would record that how the different amounts of dye for that particular amount of powder resin. The second test that we would do that I think would help quite a bit is record the optimal times of heat. Basically, what would be the best amount of time that we could leave each of these materials in for. Obviously, the LDPE, or the low density polyethylene, is going to be in for a little bit less, but maybe it would be better to keep it in for just a little bit longer than 20 minutes as suggested. And of course, the same for high density polyethylene. It might be a little better to keep it in for longer than 30 minutes, I'd say, so we can get a good even thickness throughout each of the parts. I'm thinking that what would probably result is a good 25 minutes for the LDPE and a good 35 minutes for the HDPE. Some procedures that I think should be implemented in this process would be thorough mixing of the dyes and the powder resin. This would ensure proper colorization for the whole part. We kind of saw that that wasn't mixed very well with the 4-leaf clover part. Proper measuring of the powder for each mold. So for that, I think that if we had more or less, depending on the parts, particularly more, we would have even thickness for our walls of the part. A big one that I saw that would help, and I'll touch on this a little bit more in the next slide, is keeping the screws and washers clean. There's so much time wasted just trying to screw in the washers using Allen keys and stuff like that. It just took way too long. We could definitely speed that up a bit. And of course, now when putting in two products into the machine, we should separate them by low density polyethylene and high density polyethylene. We shouldn't be mixing them in the machine. That would speed up our process quite a bit. And finally, some problems with the current process were I thought that there's too much guesswork with like the dye amounts and the powder amounts. Just for guessing too much, I think we should have proper measurements that would probably have us using always the same amounts, getting a better quality out of our products there. And to do that, we should have some cups that you just would dip them into the powder or dip them into the dye, and that would be the proper amount. You'd scrape the top off of the cup and it would be flush with the top of the cup, meaning you always have the same amount every time. All right, another problem that I thought was happening was, once again, I touched on this in the previous slide, the angle washers and screws were just too junked up. We need to clean those and then make sure after every time, after every cycle, that we try to clean out the screws just a bit. That'll maintain their cleanliness and speed up our process. And finally, I think that we should use low density polyethylene and high density polyethylene and keep them separate when we're putting them in the heating machine. That would allow for less time for the low density polyethylene, and keeping them separate will also make sure that we've got proper heating and time, resulting in better quality products. All right, thank you very much, and that was all.